how this data warehousing fits in the real-time environment. So basically, if you see this particular slide, we have here on the left hand side various channels. Channels is the way a transaction can happen. So it can be an ATM, like this is a banking data warehouse example. So on the left side you can see the transaction can happen in an ATM machine, or it can be done to the bank for a safe deposit, or directly to the branch where you can go, or doing an online transaction. So a transaction can happen through different channels. Okay, and the bank, right, they try to maintain the transactions, online transactions processing system. So whenever any transaction happens, it needs to reside in a system and do the processing for that particular transaction. So those transactions reside in systems, and those systems we call it online transaction processing systems, OLTP. So those transactions will be very fast. Simple insert or simple update or simple delete. Like you open an account, it's a transaction. It's a simple transaction, and it happens in an OLTP system. And these OLTP systems, right, they try to maintain in volume very low. So they try to maintain a volume of 3 months data or 6 months data, not more than that. Why? Because as the amount of volume increase in this OLTP system, the transaction processing time increases. That's the reason they try to maintain low volume of data. Maybe at most they can keep 1 year, so 1 year history of data. That's the reason even when we see the online statements, right, whenever we require, they provide only up to 1 year mostly. We can directly download from the system. But if it is more than that, right, we need to go to the branch and request. Why? Because that information will be not available in the OLTP system. For past 5 years, if I want my system, my data, transaction data, I can't get it. I need to go to the branch and then make a request. That's the reason these OLTP systems maintain low volume of data, so that the transactions happening on that system will be very fast. And then how do we maintain the history data, like past 5 years of data, past 10 years of data? What they do is, from the OLTP system, they archive it onto a different system, a different database. It can be any database like Oracle, SQL Server, DB2, Teradata, it is any database it can be. Again, it's a database, but that database is purely for history data, historical data, huge amount of data to store. So this is what the OLTP system, and this is what the data warehouse. So basically, data warehouse is a history repository, storing history data. That's where we call it as a data warehouse. And in between a layer is the ETL, extract, transform, and load. That is where the data transformation from one system to other system happens, like OLTP systems to data warehouse. And then the last layer comes the reporting layer, where wide range of tools in the market like MicroStrategy, Ab Initio, then SAS, then Microsoft Objects. Those tools, right, Spotfire, ClickView, those tools, what happens is they connect to a data warehouse, and we can generate reports out of that history data. So this is a typical data warehousing structure in the real time, a banking data warehouse example. Similarly, it can be in the retail side or in the healthcare side as well. And the Teradata module fits here in the data warehouse part. Earlier, before Teradata, right, most of the clients were using Oracle DB2 as their data warehouse, both as an OLTP system and as well as a data warehouse system. But the purpose was different. In the OLTP side, it used to store the real-time transactions, and in the data warehouse side, it used to store the history amount of data. Any questions here, Nikhil? So mostly we will be into this module. Teradata is a very good fit for a data warehousing, not for OLTP systems. OLTP systems are small scale in size, whereas the data warehouse, it's in huge systems. So Teradata has been introduced into the market only for huge systems. That's why it is a very good database for a data warehouse, not for an OLTP systems.
My main question here is, Teradata, it's just another database system, right? Like Oracle.
Yeah, it's just another database system. Yeah, just
Yeah,
like an Oracle DB2 SQL Server.
Okay.
But why the difference between other database systems and Teradata system is the architecture is different. The way the data is stored in a Teradata RDBMS is completely different. The mechanism is different. How we handle the data in other systems and how we handle the data in Teradata system is completely different. That's why huge amount of data can also be processed very efficiently in Teradata systems. Earlier, before 4 to 5 years, right, if you take a simple comparison, like if I want to dump around 1 billion records in an Oracle system and 1 billion records in a Teradata system, it used to be in hours basically difference. Oracle and other systems used to take hours, whereas the Teradata system used to do it in a 20 seconds or 30 seconds like that, or at most 2 minutes. That gives the difference was. Now drastically even the other systems are coming up with similar kind of architecture. That's where the time and speed are getting reduced, the difference between Teradata systems and other systems.
So my main thing was if it is an RDBMS just like the other database systems, from a developer's point of view, as long as one knows SQL, why is there the need to study Teradata?
SQL, yeah, to a certain extent SQL will be same. Either if you know a DB2 SQL or an Oracle SQL, right? Teradata is nothing different from the SQL perspective. And you need to know the architecture of Teradata, how the tables are being created, how the indexes are being created, how the partitions are being created, and if at all you write any SQL, there are some best practices or standards to be followed when you are writing in a Teradata environment. Because you can write a better SQL in Oracle environment only if you know the internal architecture of it. So you can write a behavior in 10 different ways, but one will be a very good way from the execution perspective, even in an Oracle system. Given a requirement, you can write a SQL for that requirement in 10 different ways, but which is better from Oracle standards and according to its architecture. That is one difference. And the way we create the objects or handle the mechanism is a little bit different. Mainly is the architecture difference. And then the from the production support environment, the tools, how to load and extract the data from a Teradata database system. That is different. Because they follow some different modules. Teradata follows some different modules. Main thing is the architecture. We need to know the architecture of Teradata. So that in when you are working on the SQL side or development side, right, or on the performance tuning side, once you know the very good detail of the internal architecture, right, you can write better SQLs and better queries. So let's given a simple case, an inner join, you can write, but how effectively you can improve later if it is causing a problem. For that, we need to know the architecture. That's the difference why we need to go for a Teradata or the Oracle. Even when you go for Oracle as well, you need to know the internal architecture of Oracle. For normal SQLs it is okay, but performance tuning and those part, if you want to do or design some modules, the normal forms, the schemas, the fact tables, the dimension tables, that's where the difference comes. The compare how effectively you can design. That depends upon the amount of knowledge you know on the internal architecture. Now, from the introduction perspective of Teradata, right, as I said, it's just a Teradata, it's a relational RDBMS system where the information is stored in the form of rows and columns. And Teradata, it has been introduced into the market to run the largest commercial databases. So only for a data warehousing purpose or a data warehousing environment, it has been chosen as a preferred solution. That's where Teradata has introduced into the market, only for data warehousing purpose, not for OLTP systems. And Teradata, we say it's an open system. Open system means it can run on any platform like Unix, MPRAS, Linux, and Windows operating system. So currently, 90% of the clients, right, customers are running Teradata on Linux environment. And earlier, before Linux, right, MPRAS was the operating system. MPRAS is nothing but a Unix operating system, they modified the flavor of it a little bit according to Teradata requirements. That's where, and they name it as MPRS. So MPRS is similar to a Unix operating system, but some modifications has been done on that OS layer, and they named it as MPRS. So before Linux environments, so most of the clients were running on MPRS. Now later, around 4 to 5 years ago, most of the customers have been migrated to Linux. So MPRS is now nowhere. Hardly 1 or 2 or maybe less than 10 clients might be using it, but most of them have migrated to Linux environment. And it is compliant with ANSI industry standards. As I said, from the SQL perspective, right, the syntax and semantics, it follows ANSI standard. Even Oracle or DB2 or Netezza or any database, right, they follow ANSI standard. Similarly, when Teradata follows ANSI standard, that's why the syntax and semantics of the SQL will not be much different. And in fact, Teradata SQL is much more user-friendly than other SQLs, than Oracle or DB2. It is much more simpler and much more easy to understand, Teradata SQL. Even from the writing perspective, it's a little bit more easy. And Teradata, it runs on a singular and multiple node. In the coming slide, I will explain you what a singular and multiple node means. But for time being, just note down that point. This Teradata runs on a singular and multiple node. And Teradata, it's a database server, we say, where we can access to various clients. From various clients, we can access Teradata database server. And parallelism is one of the major feature of Teradata, which can handle effectively humongous amount of data in a very effective way. That's why Teradata RDBMS is a little bit faster than other RDBMS systems in the market because of this parallelism feature. Other databases also have some parallelism mechanism, but they differ in the way they handle the parallelism technology. And Teradata, it can support concurrently a number of users from various client platforms using a massive parallel processing architecture. Teradata, it's a very huge system, and the architecture, we call it as MPP architecture, massive parallel processing architecture. Not even Teradata, any other huge systems like in the current market like Netezza, Exadata, Big Data, Hadoop, they all have, these all systems, right, handle huge amount of data in a very effective way. And all these platforms comes under MPP architecture, massive parallel processing architecture. Any system which can handle massive amount of data in a parallel fashion, we call it as an MPP architecture. So if someone says MPP systems, then all these systems comes under it. Big Data, Hadoop, Teradata, Netezza, Exadata, all this, Greenplum, Vertica. And excuse me, if you look at the history of Teradata, right, it has come into the market in the year 1975 and released its first product in 1979. And then every year many new features and fixes have been introduced into that Teradata system. And in the various financial years, different kinds of releases have been released into the market, just like Oracle 8i, 9i, 10i, 11i, 12g, 13g, like that. Even Teradata has versions V1R1, V1R2, V2R1. So currently, in the current market, right, the clients are using Teradata 12, Teradata 13, and Teradata 14. So from the user perspective, right, it will not be much different unless or until a new feature which requires a new syntax and semantics. Apart from that, most of the things will be common in any release. Few performance improvements will be there, but that will be from the system perspective, not from the user perspective. Unless until like in TD12 query rewrite feature was introduced, in TD13 scalar subquery and no primary index feature was introduced. So it requires a different syntax, these features. That's where the difference comes. And in TD14, temporal and columnar features are the new one which has been introduced into TD14. So most of the SQL stuff will be common. Only for these features, a new SQL also has been introduced. That's the difference. So later in the SQL part, right, when we are learning, we'll be covering the regular SQL part and then these features, how the syntax and semantics have been introduced for these features. These things also we'll be looking at. Any questions, Nikhil, up to here?
Oh no, I'm good.
Okay. And this slide, it talks about the basic high-level architecture of Teradata. And if you see this gray color box, right, this can be considered as a node. A node is a machine. My laptop is a machine. So this can be considered as a single node. So if I install Teradata in my laptop, right, so these are the components which get installed: parsing engine, message passing layer, and access module processor. So these are the components which get installed in my machine. So I can call it as a node, single node. The laptop will be a single node system, one node system. Multiple node means more than one machine. So I can install Teradata in my system, and same version I can install Teradata in your version, and then configure both the machines to act as a single system. That is what multi-node system, more than one. And it is called as an MPP architecture, massive parallel processor. So more than one, we call it as an MPP system, massive parallel processor. Only one, we call it as an SMP system, symmetric multiprocessor. Single node or a multi-node. So Teradata runs on a single node or a multiple node. Maximum we can have 4096 machine, 4K. 4K machines we can have, 4K nodes we can have for a Teradata system. So that is the maximum limit. Currently Walmart is the biggest customer we have from Teradata, and they themselves use around 900 nodes. So I don't think any customer who has currently exceeded 1000. Earlier the limit was 1000, but later in 2012, right, they have extended it up to 4000 nodes. So any customer can have maximum of 4000 nodes. But currently only 900 is the maximum, and Walmart is the biggest client which is currently using those number of nodes. And coming to the internal components which get installed from the Teradata perspective, and the basic functionality that component works is, first thing is a parsing engine. This parsing engine module, what it does is, any request which we submit to Teradata server, okay, it performs the syntax and semantics checking. Syntax, semantics. Apart from that, it has the intelligence of optimization, how effectively it can optimize the request, and then it can distribute the data. Suppose if I am loading the data into the Teradata server, this data set where it should be loaded onto the Teradata box, that intelligence this parsing engine has. So it has the syntax, semantics, optimization, and distribution. So these are the, at a high level, these are the four types of functionality the parsing engine does. Then comes the message passing layer. Message passing layer is like a communication protocol. Communication protocol between two processes. So parsing engine is one process, access module is one process. So it acts as a communication protocol between parsing engine and access module processor. And what is an access module processor is, it has the functionality of a physical processor basically. What exactly a physical processor do? Pentium, the P3 processor, P4 processor, Core i7, i5 processor. What does the physical processor do? All that functionalities this access module processor has, and it has the interaction or does the operations on the disk. It has the functionality to operate on a disk where the data gets stored. Suppose if parsing engine says, okay, load the data into this particular disk, okay, then AMP will do that. Or if parsing engine asks, okay, get me this particular table data, AMP does that functionality. So it performs the functions on the disk basically, performs the IO operations and the processing on the disk where the data gets stored. So here in this a simple configuration, we have one parsing engine, a message passing layer, and then 4 access module processor, where each processor is allocated to a disk, and this disk we call it as a vDisk, virtual disk. That means it is basically a collection of physical disks. Suppose I have a physical disk of 10 GB each, so a virtual disk can be a collection of 10 physical disks, and collectively we call it as a vDisk, virtual disk. And here in this particular slide, right, what it is shown is, client is inserting some around 12 records of data, 12 records into a table. So we can see the data is not stored in a single disk. The data is distributed across all the AMPs. That is the benefit of Teradata system. The data gets distributed across the ARMs so that the processing gets distributed across the ARMs and the time to process get reduced. Why? Because the data is distributed across all the ARMs. So whatever task we submit, the task will be broadcasted to all the ARMs and all ARMs will perform that particular task in a parallel fashion. That's how parallelism works in Teradata. We are sending a request, the request will be sent via the message passing layer to the access module processor, and each ARM will be processing the task on that particular subset of data. And each ARM is performing the task and all the ARMs are performing the task in a parallel fashion. That's how the processing is very effective in Teradata environment. Even if multiple requests are sent, suppose assume there is one parsing engine and I am connecting to the server and you are connecting to the server. So basically two requests are sent. One is myself and the other is you. So parsing engine will handle the two tasks, task 1 and task 2 in a parallel fashion. It will check the syntax, semantics, optimization, and if it's a loading, then the data distribution, or if it's a retrieval, then the retrieval operation. All the four functionalities will be performed parallelly for both the tasks, for my task and your task. And then once it is done, then it will send the task to all the ARMs. So each ARM will be having now two tasks, one task of mine and one other task of yours. So two tasks will be again handled in a parallel way without any bottleneck. So the parallelism, right, it is built in each and every component, right from the top to bottom. Parsing engine, message passing layer, access module processor. That's how parallelism works very effectively in Teradata environment. Any questions here, Nikhil? This is a little bit at a very brief level. In the coming classes, we'll be going in depth into each and every component and then see what exact functionality or the sub module it has. But at a very high level, is this concept clear? How the parallelism or how the data distribution or how the data retrieval happens at a very high level?
Yeah, it's clear at a high level.
Yeah. Okay. Now, Teradata, it has Teradata means it's 1000 GB, 10 power 12 bytes of data. We call it as a terabyte, and these are some of the common differences between Teradata system and other systems, like unconditional parallelism. Like we are not restricting the parallelism concept anywhere. By default, we have been defining each and every component to act in a parallel fashion. Of course, there will be a limit on the number of tasks each component can handle, but up to that, the parallelism is by default. And whereas the other RDBMS said, it is basically a conditional parallelism. The parallelism is built on certain conditions. Only if this is the cases, then it should be happening in a parallel way, or else no. And most importantly, one of the other major differences, Teradata is a cost-based approach, whereas other RDBMS are a rule-based approach. So they have defined certain rules, and according to the rule-based, the optimization works. But in Teradata, it doesn't act like that. It is a cost-based. At the runtime, it will estimate which will be the best way to execute. That is one more major difference between Teradata and other RDBMS system. And Teradata, it has been designed for decision support systems. That is the data warehousing. It's not DS, it's a DW, data warehousing. Data warehousing, we also call, the other name for that is also a decision support system. Why? Because we can derive certain decisions or make certain decisions on a data warehouse. Using the huge amount of data, we can make certain decisions. That's why we call it as a decision support systems. And this is one of the major difference, shared nothing architecture, whereas other RDBMS is shared architecture. Whenever someone asks what is the major difference between Teradata and other RDBMS, this is what they expect from you, shared nothing architecture. Teradata is a shared nothing architecture. What exactly it means is, in this particular slide, right, we are seeing that each ARM is associated with a vdisk. That means this disk will be processed only by ARM1. It will be never shared across any other process. So ARM2, 3 or 4 or any other process, right, cannot access the vdisk1 which has been associated with ARM1. That is, this data is not shared across. That's why we say it's a shared nothing architecture. The data is not shared. And that is one of the major difference between Teradata and other RDBMS architectures. And this is one of the major difference too. And
I didn't get that part. Not shared with what?
shared nothing architecture. Teradata is a shared nothing architecture. That means the data is not shared across any other process. Only AMP1 can access this particular disk data. That's the meaning. This data will not be shared across any other process, AMP 2, 3 or 4. Each AMP is associated by a vdisk, and that vdisk is not shared across any other process. So if suppose AMP3 wants to access this particular data block, it can't do. Only AMP2 only can access this particular disk data.
Okay, so what is the advantage of that, to have a one-to-one relationship?
So that the consistency will be there, data integrity, and can be maintained in a very effective way if it's not shared. And suppose if there is a requirement, like AMP3 needs to access the other AMP's data, then in certain condition, in certain situations it is required. At that time what we do is we do data duplication. Like we copy the data from this AMP to this AMP, or from all other AMPs to this AMP, and then perform the data processing. From the architecture, this is how they follow. Teradata has followed in this particular fashion, so that the data is not shared across any other process. Each AMP is associated with one disk, one vdisk, and that vdisk is a multiple or a collection of multiple physical disks. That's why we say Teradata is a shared nothing architecture. The data is not shared across any process. Only the process associated with it can access the data. Whereas in other RDBMS, we see the concept of shared architecture. Like same disk will be there, single disk will be there, or a single vdisk can be there, but that vdisk is shared across multiple processes. Process 1, process 2, process 3. So 3 processes can access a single vdisk. And this is a very old difference, and it has now been drastically reduced, like terabytes of data and gigabytes of data. And this one, index usage for better retrieval, faster retrieval, and for better storage. Like index mechanism, right? It is generally used for fast retrieval. If you want to access data very fast, right, indexes will help you to achieve that. So in other database also same thing. If an index is there, then the data retrieval will be very fast. But in Teradata, apart from that functionality, a better storage can be done with the help of an index. Now here, you are seeing a very good distribution of data across all the AMPs. You have some 100 records. Each AMP can hold a maximum of 25 records at minimum or maximum, at least 25 more. So that the data is distributed across the AMPs in an even fashion. That is because of the index concept or mechanism. That is happening because of index mechanism. So in Teradata, with the help of index, right, we can see a better storage as well as faster retrieval. Both are possible, and it can handle billions of records anyway in a very efficient and effective way. And from the capacity, yeah, it can handle huge amount of data or process millions of instructions per second in a very effective way. Parallel processing, that is one particular feature which makes the Teradata RDBMS faster than any other RDBMS systems. And it's a single data store and can be accessed by network attached and channel attached systems. So what does this clause means is, basically 2 types of environments are there. One is a network attached, like all the systems like Linux, Unix, Windows, MPRAS, Solaris, all these comes under the network attached systems environment. And the mainframe, it comes under the channel attached environment. So if you are accessing through a Linux environment or an MPRAS or a Solaris environment client, then we call it as a network attached system. And if it is a mainframe, then we call it as a channel attached system. So Teradata can be accessed through 2 different environments, network attached and channel attached. Fault tolerance, it can automatically detect and recover from some of the failures. And data integrity is like in any database, right? Data integrity means if at all any transaction happens, it should happen completely or it should get rolled back to the previous state. then we say a transaction is successful or the data integrity is maintained. So even in Teradata, the data integrity is there. Most of the times we see the data integrity in suppose in case of an ATM transaction, right? Sometimes transaction might fail. So if you look at our accounts, right, we see two transactions there at that time, a debit and a credit. Suppose you withdraw some 1,000 rupees, but the transaction happened, but due to some reason you didn't receive the amount. So it's not a successful transaction, it failed. But in your saving or in your bank account details, right, you will see 1,000 rupees have been deducted and again 1,000 rupees have been added to your account. That is because of the data integrity concept. Transaction failure rate. Transaction should happen complete or it should get rolled back to the previous safe state. Then we say the data integrity is maintained. And then scalable growth. Teradata allows expansion of the system without any performance drop. Suppose currently I have 4 nodes for my business, but my business is expanding gradually and my current environment is not supporting that. It is causing some huge bottlenecks. So I want to expand my system. So I can add additional nodes to my existing system. So what will happen is the performance of the system will be increased in a linear fashion. Suppose now I have 4, I have added additional 4 nodes with the same configuration. Then what will happen is my performance of the system will get doubled. So that is what the scalable growth means. It expands in a linear fashion. And SQL, it serves as a standard access language to access the Teradata server, performance the data control.
When you say scalable growth and increase in number of nodes, that means the other 3 layers are also increasing, like AMP and the physical DBs are also increasing proportionately,
yes, yeah.
Right?
Yeah, true.
Well, what is the normal ratio? I mean, for one node, how many? Is there a correct AMP?
We have a limit like 128 processes we can have, a combination of P's and AMPs. For one node, I can have 128 combination of P's and AMPs. So like I can have 64 P's and 64 AMPs, or 32 P's or 96 amps, like that, or 1 P and 127 amps, like that. So basically P's will be less in number and amps will be more in number in any environment, because amps are the one which handles the access to the disk. So that's when we see that the amps are more in number than P. And P always already we have a limit, like it shouldn't exceed 1000 P's per system. A system can't have more than 1000 P's, whereas amps, like we can have a maximum of 16,000 amps per system, not one per system. 16,000 is the limit.
Okay. You're saying PEs or PDs, like physical disk?
P, passing engine, P.
Okay, passing it. Okay.
Yeah. Physical disk is like you can have a collection of physical disk, like 10 physical disks into one VDisk, and each process can handle that 10 physical disks. So 10 physical disks, I will treat it as one VDisk that is associated to AMP1. 10 physical disk, the virtual disk 2 associated with AMP2, like that.
Okay, so AMP to physical disk is 1:10.
1:1. 1 AMP
1:1.
should have one VDisk, and VDisk can be any number. It can have 3 physical disks or 4 physical disks or 10 physical disks. That ratio is not generalized. It can be anything. From the topics perspective, right, like we'll be working on Teradata 13 environment, on the Windows environment for most of the topics, and for few topics we'll be working on Teradata 14 on a Linux environment. Okay, and for you people to practice, you need to install Teradata 14 version, or Teradata 13 is also available, but Linux version, both are Linux versions available in the market, in the Teradata website currently. So if you want to practice, then you can install Teradata 13 or Teradata 14. Mostly we'll be working on, most of the stuff we'll be working on Teradata 13 Windows environment for the practicals which we learn here, and then for few concepts, technical concepts and some sequels and some production support jobs, we'll be working on Teradata 14 Linux environment. And from the topics perspective, right, we will cover a little bit of an introduction part, like the one which we covered today, and then later we will be moving on to some of the in-depth concepts of each and every component, what all sub-components it has, and what is the basic functionality of those sub-components. And then we move on to the technical concepts, like from the recovery and production of data, what are the different concepts or terminologies are used in Teradata environment, and then the technical concepts in SQL environment, what are the different technical concepts we need to look into from Teradata perspective, how they are handled in Teradata environment, those things. And then the data retrieval part, how does the data get stored and how does the data get retrieved back, what is the mechanism involved. Then the basic GDL and DML part and the DCL part, like creating the tables, stored procedures, views, checks and everything, and how you can handle that, what are the different clauses or what are the different functions available. And then few sub-functions related to string operations, arithmetic and logical operators, and analytical operators. And then the different join strategies or the join types and how they are handled or implemented in Teradata and how does it work. And then some other external commands like help, show, explain, and collect statistics. And then we look into the various objects, what are the different objects can be created in the Teradata environment, these things. Then a little bit on the admin part, DBA, because why we cover this concept is in order to practice some of the above stuff, sequels and other things, right, we need a little bit of admin part. For that sake, we have introduced even this learning of the memory spaces, how the space mechanism is handled in Teradata environment, and then the DCL part, data control language, how to access restricted objects, or how to grant or how to revoke the access rights, those things. So in order to practice for us on the environment, right, these modules also will help. That's the reason we are covering the DBA part as well in our modules. And then the different types of transaction modes, how we can differently execute the transactions in different ways in Teradata. And then comes the performance tuning part. What are the best practices involved in writing the sequels, and what are the different ways or different criteria we need to look into whenever we are writing some sequels, those things. And then the production support jobs, the basic ETL part, using Teradata load jobs, fast load, fast export, multi-load, TPUM and TPT. These 5 different tools, how we can handle to perform the load and export jobs, and what are the different failures these jobs will fail in the real time, and how do we rectify them. So we'll be covering all those real time scenarios, how a job can fail, what are the different possibilities a job can fail, and how do we rectify them, or how do we recover them. Those things will be seen in this particular topics, production support jobs. And then apart from this, the new features, like as I said, in Teradata 13, scalar subquery, no PI, and in Teradata 14, temporal and columnar features, right? So we will be discussing some introduction of what that particular feature talks about, and then the syntax and semantic, the SQL part. For that particular feature, how we write the sequels and how we execute them, those things. And then from the material perspective, I'll be giving Word documents and some PPTs and some HTML, okay, which can be helpful for you if after this training, if you are willing to go for certification, right? Basics and Teradata SQL for 12, you can go. Any questions, Nikhil? You know? And apart from this, like if you have any other topics, like from, since you already said you'll be working on this, if any other topic is of your interest or which you know you'll be working and it has not been included here, you can let me know, then we can discuss once our regular training is completed. Like once we cover all these topics, I can take some additional 1 or 2 classes for the additional topics which you require from your job perspective.